Okay, so in this video, you and I are going to walk through some code together. And the reason why I wanted to do this is because I have had so many different discussions with JavaScript developers and tried to explain the way that I think about how to write JavaScript code in what I call a robuster way than what most front-end developers are used to. Now, I'm not saying that this is the only way to write code. I just want you to see an example of the way that I think about structuring code as I progress through a project or building a feature, basically. So one thing that I try to have in mind, like the philosophy that I follow, is that the code that I write is not allowed to infer anything about the system. And basically what that means is that when I write a function, I try my absolute best to not assume anything about what the function is going to be doing, or rather what is happening higher up in like the chain of events that take place. I had this discussion with a colleague of mine just the other day, and he was saying that I was trying to tell him to do a little bit of input validation for his function because the quality of the code he writes will actually go up if he thinks about these things. And he said, "Well, no, I don't want to do that because that's a hassle and it's it's code bloat, and I know that certain things are true about what's happening earlier in the program." And I said, "Yeah, that is true right now, and the only reason you know that is because you are working from the perspective that you know everything that's going on in your feature. But if I come to your code and I have an issue with one function or one piece of your code, I don't know that." And so my philosophy is that to truly write a modular code base, you have to make every single little piece of your code base as well as you can. And I hope this can illustrate a little bit of the way that I think about these things. Now, this is not a perfect example, but what we're going to walk through now is an add function. We're just going to add stuff together. So what I usually do when I set up a project like this is that I create a folder that will hold the functionality that I need. So in this scenario, the first thing we want to do is that we want to add two things of the same type together. And the way that I do that is that basically the folder contains all of the functionality that I want to expose to the outside world, and then I put an index file in the folder which basically imports all the internal files and exports what I want to be the public interface for this module. Now, as you can see here, we have a few things that we can add, like a number, strings, arrays, objects, booleans, and then we have something called any of any type, and we will touch on that in just a moment. So let's start by looking at the tests. So the way that I do this is that I create this internal test folder in my library, and this is like what you're seeing now is the basic structure of almost anything that I write. And for those of you who have been doing a little bit of like node modules, like development or so forth, this is actually very similar to the way that Lodash structures their libraries, structures its library. And I think that's very powerful, a very powerful concept. Let's call it, if we need to put a name on it, let's call it library-oriented development. I argue that we should, if possible, write the feature and the code or the component, if you're working in React or Angular or something like that, as if it was a node module. And this is a node module. The only difference between this and a real node module is that there should be a package.json file here that points to this index file, and this would then be an npm package per my definition. Anyway, let's start and look at the arrays test I have here. So I use Jest for most of my development, if not all my development, if I can. I love that. So the first unit test is going to check, do we have a module? That's just a sanity check to make sure that this import is actually getting something. And then we have the first test. So we expect that after doing an add of two arrays, we're going to be left with an array of 1 and 2. So if we go down and we just run test watch, boom, 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 yeah. So as you can see, all the tests are passing. So like I'm not going to show you more around jest, that's a different video, but I just wanted you to know that all of these tests are actually passing, so all the examples are actually functioning as we intended. So and then we have the actual value. The evaluation here is correct. This is simple stuff. So all we have is a function that takes two different arrays and adds them together, or concatenates them. Now this is a fairly trivial thing to do, but the thing is, most developers stop here, and that's where I think we're going wrong. I think that what should be happening is more along the lines of this. So let's start by trying to put an array and a Boolean value together. What happen? Can your function handle that? What happens if there's an array and an object? What does your function do? And then we have a number and an array. What happens if there's no input? What happens if one of the inputs is undefined? And what happens if there's just one? You know, like one left-hand parameter. Like, these are cases. These are actual cases that are absolutely possible. Like, you know, feasible that this could be happening in the consumption of your function, or the caller of your function may actually make these mistakes. It's not a big thing, but this is, you know, genuine situations that can arise. And then we have this little function down here, is failed array add, and we will touch on that in a little in a moment. And all it basically does is that it takes an array and evaluates if, yeah, I'll talk about that in a moment. But that's the test. And now if we go to the add array function, let's look at that here. This is all it is. It takes two values, and because JavaScript is loosely typed, I have no way of knowing what A and B are. I can't know that from this perspective. So I have to check. So I do a type check, and I check if A or B is not an array, then I simply return a default value. Otherwise I will concatenate these two arrays together. And the power of this is that my function now does not make an assumption about anything else. It is as well thought out, as well structured, or reasonably well structured as I can make it. So the function's quality is as high as I can make it. And that's the mentality I'm going for. Now, as you can see, I'm returning an empty array if something invalid input is coming into the system. Like basically, if the function gets called with, you know, something unexpected, I return a default value. Some people will tell you that you should throw an error if something unexpected happens. I personally prefer returning default values. And the reason for that is that if you throw an error, odds are that you're going to break something in the code. And the most common argument I get against this is that, well, but maybe you have a bug and you don't have a way of knowing if there is a bug if you don't communicate that something unexpected happens. And I usually answer by saying that is true, and for some cases you want to throw an error. I argue that if something goes wrong at start time, like if your system, your server or something doesn't have access to the database or something like that, you can't start your application. Absolutely, then you should throw an error, because there's no point in going forward. But I argue that if there's a logic error or a coding error or something like this, returning a default value is actually to be preferred, because odds are that if all your code is returning a default and has no way of throwing an error, there's two things that can happen, especially in front end. One is that the interface will look different, like something like there will be some type of default state shown to the user. And what's going to happen is that the user is either going to identify, or you and your development team are going to see that, hey, that's an issue, and you're going to fix it, which means that it's going to give you as much of basically as much value as if you had an error of some sort thrown to the user and so forth. The problem with throwing an error is that very often throwing an error is something that is very destructive. It may actually stop the user from continuing using the application, and that's actually something that I think is very important, because maybe the piece of code that you have an issue with doesn't actually affect the user all that much as they're using your application. Maybe your bug, this subtle bug that you have, never even gets, it never gets to the surface. Nobody ever notices it because it's such a discrete thing. And I would rather have, that's my philosophy, I would rather that my system runs all the time and is really robust, rather than having it crash for the user so that the user is stopped from getting the value that they're trying to get from my application. Anyway, let's move on to the next thing. So let's have a look at booleans. This is also fairly trivial. Now, if you don't know this, boolean values are actually, these words, true and false, are really only zeros and ones. So adding them together, if you add two trues together, you're going to get 2. Like, it's going to be evaluated to a number. And as we can see here, these are the base cases. You put 2 true together, 2 false, and 1 true and 1 false. Easy peasy. And then we have the same type of evaluation strategy here. We look for invalid inputs. We look for unexpected things that can happen to our function. So what happens if you add a 1 and a true together? Well, because these are basically, this function is supposed to add booleans together, we're not allowing that, even though these two things are actually equal, if you think about it. But they're not booleans and so forth. And then you have different values that can be added together. And if we also have this isFailed Boolean add function down here, which will basically just look at a number and see if, or rather a value, and check, is this the default return value for for add booleans if it fails if it fails to add two booleans together. So here we are. Now I use Lodash for this, and basically it's the same type of evaluation. We check, are both of these booleans? If none of them are, or if one of them isn't, then just return a default value of some sort. Otherwise, add them together. And isFailed Boolean add will, as you see, just make an equals check to check whether or not this value is equal to the default that we're returning up here. And this is also true for numbers. Like these tests here, they basically check the same thing. So the philosophy is the same. And it's the same thing for objects. It's the objects adding is going to merge two objects. As you can see, there's just one basic test where you have two objects. It merges them together and returns the merged values. So if we look at objects here, as you can see, it's basically the same type of idea that you do upfront validation. You're upfront about what your function needs in order to function correctly, and if it is given something it's not expecting or something that it doesn't want, you just return a default value and call it a day. That's what I argue is a these functions are very safe. They're very safe for anybody to use. They will never misbehave, unless of course the logic is a problem. But I often very often see people make a lot of assumptions about the input. All right. So we have add strings as well, which is basically, yeah, you kind of get the idea. Now, so here I am with my little suite of functions that do one thing, and they do one thing really well: adding arrays, adding booleans, adding numbers, adding objects, and adding strings together. These modules do this extremely well. So now I want to create something more complicated, because maybe I'm interested in having some nicer, higher level abstraction on top of this. And this is where I argue a lot of functional value comes into play. So what I do to add anything of the same type is this: I import all my modules that can do these different addings, like to add all these different values together. And I take an A and a B, and then I have some type of fallback value that defaults to -1. And now I can actually take A and B and securely run my functions on these values, because I know that my functions are safe. They are pure. They are not going to misbehave. They're not going to throw any errors. They're just going to like string add here can only be one of two things. It can be a successful concatenation of two strings, or it can be an empty string, because I know that add strings is going to return an empty string if these two don't match up. Same thing for Boolean add and array add and so forth. I know that there's a default value. And then finally, I can actually just walk through. That's where these isFailed string add functions are coming from, so that I can actually check if the return value of one of my functions is a failure or a success. It's easy peasy. And that way I can always return the same thing. That's also a very rule that I try to follow. I don't throw errors, I don't return errors. I return the same thing in all situations. It's make things as deterministic as I humanly possibly can. And then evaluate on as the caller is charged with evaluating whether or not it was a success or a failure. Anywho, with this logic, I can now get a single abstraction that does all of this together. And I export that just as any other export, and here we are. So now my library allows the caller of, or the user of my library to either do one of these individually or all of them together. So this is an example of what I think is very powerful, where a small piece or several small pieces can be added together in order to create a larger piece, something that is like, this is to me composition at the conceptual level. This is the type of composition that you can get when you abide by these what I call functional styles, or the principles that functional programming kind of brings to the table. This is not necessarily functional programming, it's just something that I like to do, and I have kind of learned by using a functional style of programming with a lot of small pure functions, so it becomes very natural. So this is the first step, and now, as you may have noticed, that there's a second module here. So here we have a larger piece or a larger function with more complexity that is made up entirely of small functions that have less complexity but are very robust and very well made. And this larger function is now more advanced, has more functionality. It also has its own tests, and it's also completely safe. This can never break. Nothing here, this will never throw an error either. So what happens if we wanted to increase our complexity a little bit? Because right now we can only add two things of the same thing together. What if I wanted to merge things or add something to something else? Well, then I have this little bit, a bit more fancier module that is called add to. So let's look at the tests here. So it has a module. It can add two numbers. Well, we know that seems to be a fair thing. I mean, if we want to adding to something, you should be able to add 1 to 1. Same thing here, adding two booleans should work. Adding two arrays should work. And adding one object to another, like merging these two objects, that should work as well. And then we have two strings. You should be able to add foo to bar. Same thing with numbers and a string. You should be able, because JavaScript lets you do that. So the behavior is that if you add a string and like a digit, they should be concatenated correctly. Same thing for Boolean. And then you have a Boolean to a number, which is, if you remember what I was saying, like false is actually 0. So 0 plus 1 becomes a 1. And then add anything to an array. This is a little bit of a contrived example, but basically, okay, you give it an array and some other value, and all of a sudden you're supposed to be left with an array with that value added to it. Easy peasy stuff. And this is where it gets this function gets a little bit more fancy, where basically you're saying that, okay, I want to add a value to an object, but in order for us to be able to express that in a sane way, we need to actually give it a third input parameter, which in this case I call options. This is just like a way for me to very easily expand on the functionality of this function if I wanted to in the future. And then finally, there's a default behavior. What happens if you add a value to an object but you don't specify a property name to put this value inside of? Well, then it's just going to default to some behavior. So this is like these are just the tests. So let's look at the actual implementation of this now. So now this is a function that is even one level more complex than what we have been talking about earlier. But what I like about this is that now I have the option, like the first two input parameters is the exact same interface as I have for adding any of same type. So I can actually use that. Add any of same type. I can actually now use this function to get a return value, and I can also evaluate what that's going to be, and I know that add any of same type is going to return -1 if it fails. As you can see here, if the value is equal to -1, then these two, A and B, are not the same value. It's not possible that they can be the same value, because my function, this library that I'm importing, is promising me this. That's the contract. This is going to add two things together if they're of the same type. And if it's not possible, it's going to return me a -1. So if it can, we return that value and we're done. But now, since we have more functionality on top in this function than in our previous function, now we can do a little bit of assumptions about the values, because we now know that they are not of the same type. So that's one thing we know. The next thing is that we need to check if A is equal to an array. Well, if it is, then we can actually concatenate whatever B is into A. And that's the way we got that. You saw that test earlier where we just add whatever value is put into. If there's an array plus another value, we simply add it together. And we do both for both A and B, so that regardless of which order you're putting things in, you're going to get the same behavior. And then we have the get function that gets the prop name from a potential options object. Now this is very important. Get is my absolute favorite function. And get is my favorite function because I have remember what I was saying, I have no idea what this is. I'm always checking what my input is because there is no way for me to know what it is. Options may or may not be an object, I don't know. So why not just use get, which allows me to safely extract the prop name from options if it is there. And if it's not, it's just going to return undefined, which is a safe way of accessing properties on an object. I often see people who do like deep indexes like foo.bar.bas. This is very dangerous because if bar isn't here, all of a sudden your code breaks. Anywho, then I do an if condition. I check, can I merge this property? And that's a simple function that checks once again. Notice that we're doing an safe evaluation here. A and B and prop name. So it checks if A is an object or B is an object and there's a prop name, then we know that we can actually add these things together. Now all of our conditions that we need are met. And then finally we do the merge, which is also fairly straightforward. So we have A and B and a prop name. We create a copy of the, a mergeable copy of the object because we don't want to mutate A or B depending on which one is the object. So we check, is A the object? If A is the object, well, okay, then we set to merge with the prop name to the value B because A is the object that we already have. So, and then we spread all the properties of A onto our copy and then overwrite whatever to merge has now become. And we do the same thing for B, which is now going to return us an object where the key that was provided through prop names is going to exist. And if that key already was on the object, it's going to be overwritten with this new value. Sorry to get a little bit convoluted there. It gets a little bit, it sounds more advanced than it is. I hope you could follow. And finally, if we can't solve it in any other way, we simply add these two values together. Now, what has happened here, which I think is what I want you to take away from this, that we started by simply stating that, hey, we will have an add function for adding arrays, one for booleans, numbers, and so forth. So we started with this tiny little function, and then we built another function on top of that that could become even more sophisticated through composition, and then finally that even more sophisticated function has now become a really sophisticated function, or like a level more sophisticated, and we can actually reuse the logic we already wrote. And by doing things like this, like having the mindset that I'm gonna make every single piece of my code as well as I can, doing input validation and like all of this stuff, and not assuming anything about what's happening earlier in the program, you can actually, in my opinion, write much more robust code. And I think that's a valuable thing to know how to do. Hopefully this was useful to you. Now, I'm not saying that this is the way that everybody should write their code, it's just the way that I like to think about the code that I write. So I hope this made some sense to you, and I hope you have a great day.